High pressure has returned. It's brought a lot of cloud and some cooler air with it, but it's a largely settled week ahead going into the bank holiday weekend. Bank holiday for many, but not for all. However, could Hurricane Erin, by the weekend, an ex-hurricane, shake things up for the final week of summer? That's the big question I'm going to be asking in this week's Met Office Deep Dive. Hello and thank you for joining me. We do these every Tuesday. There are in-depth discussions of the UK's weather and beyond for the next few days and beyond. And we enjoy hearing your feedback. Do let us know if you like what's covered in these deep dives. Let us know if you've got any questions. We often answer the questions that you put in the comments in the Weather Studio Live that we do every Friday. So yeah, plenty of opportunity for you to get your questions in and get some answers from us here at the Met Office. And if you're watching on Spotify, congratulations, you are one of a growing number who can enjoy these forecasts and the rest of our forecasts on our Spotify channel. If you're not aware that we are on Spotify, do check us out on there. But of course, continue to subscribe on YouTube, continue to tell your friends about these because we love making them and we want to reach as many people as possible. Now, Hurricane Erin, beautiful thing from the sky, of course, but already has brought some tragic devastation to parts of the Caribbean, Cape Verde. There was some tragedy there from very heavy rain over the weekend. This satellite image was taken when Erin reached Category 5 status on Saturday and reached sustained winds of 160 miles an hour at its peak. At the time of recording, it's now Category 3, but it was a remarkable and very fast transition from tropical storm to a Category 5 monster in just 24 hours at the start of the weekend. Now, the very brave hurricane hunters captured some extraordinary footage, which we can see here. How they managed to fly a plane into the center of a hurricane is beyond me, but yeah, you get these incredible images with the eye there the top of the screen. You can see the blue sky. I think the sun made an appearance in one image I saw as well through the eye of the hurricane at the weekend. And look, the plane's there going back into the eye wall, some heavy rain coming back in. So yeah, extraordinary footage from NOAA's hurricane hunters in the US. Now, Hurricane Erin is projected by the National Hurricane Center, this is the official track, to stay away from directly hitting land areas, thankfully. This is the projected track, and it's expected to move north and then curve north-eastwards into the North Atlantic over the next few days and into the weekend, before eventually, this is 2 a.m. Sunday, the white circle by that stage indicates that it's post-tropical. That means it's no longer technically a hurricane, but an ex-hurricane. Now, the difference between the two is quite technical, but it's essentially a difference in the structure and in where the fuel source comes from. So hurricanes are fueled by very warm seas, 26.5 degrees Celsius and warmer. Once these hurricanes move into cooler waters, they no longer get their fuel from the seas and oceans, but they get their fuel source from the horizontal temperature gradient. We can go into more detail about this in another deep dive, I'm sure, but essentially that causes a change in the structure of these hurricanes. They become ex-hurricanes, more like mid-latitude lows. So that's happening over the weekend. So before we go any further, technically no hurricane could hit the UK or will hit the UK in the near future because the seas surrounding the UK are simply not warm enough. They're some 10 degrees lower than you'd expect to sustain an actual hurricane. But you can get these ex-hurricanes coming in from the Atlantic, behaving more like mid-latitude lows, but injecting additional uncertainty compared with other lows as they move into the North Atlantic because of a number of factors which I'll go into in this deep dive. But this is the official track by the weekend. Sunday, no longer a hurricane, but still a fairly potent mid-latitude low pressure. And although it's not directly going to hit these land areas across the Caribbean and also the eastern portion of the United States, it will still bring some life-threatening impacts. So there have been warnings, there have been evacuations in some areas. This shows life-threatening rip currents and the risk of high risk all the way from Florida up to South Carolina, North Carolina, all the way up to the northeast there, New Jersey, for example. These are rip currents, so the red shading there at the coast shows a high risk of life-threatening rip currents. Meanwhile, there'll also be a significant storm surge, and this shows where the storm surge will be worse. This is where the low pressure and the winds combine to increase sea levels along the coastline, 2 to 4 foot there across that part of North Carolina and its coastline. So there have been evacuations across parts of the US. Even if Erin is going to stay away from directly hitting these land areas, it's still going to produce some very severe coastal impacts and life-threatening rip currents as well as storm surges. For the UK, though, it is injecting some uncertainty, as I mentioned, into our forecast. Now, part of that is down to the track of Hurricane Erin, and I'm going to go into that now, but I think what's more interesting is what it's going to do to the jet stream, and that's what I'll cover later in this deep dive. So taking a look at the track of Erin, like I say, at the time of recording, it's moving its way north across parts of the Caribbean. If we zoom out here, there's the jet stream. There are these areas of low pressure across the Atlantic. And if I press play, and I'm also going to put on the track of Erin from various different computer models, there are 50 or so projections from the European computer model here. Now, they're all following the same track, so they're all coming up as this more or less solid line during the next few days. They're all agreeing that Erin will follow this sort of track. That's the National Hurricane Center track, and you can see all these different colors indicate a different track from a different computer model, and we're just playing it forward here, and we're going into Friday. Still, by Friday, virtually all computer models have Erin in more or less the same location, just off the eastern seaboard there, and to the start of the weekend, and heading towards the jet stream. There's the jet stream. And then interesting things start to happen. And I liken this to if you're in a queue of traffic joining a motorway, and the driver in front might spot an opportunity to join the motorway. Let's say the motorway's busy, but if they spot a gap in the traffic, they can join it. And then suddenly they're off. They're flying away at quite a high speed. But the next driver might not be able to get into a similar gap for some time. And so whilst those two drivers were quite close at the start, the one driver having joined the motorway just a fraction of a second earlier than the other means that they are minutes or half an hour or so further ahead in their journey compared with the next driver. So imagine Erin's moving along, not much to push it along at this stage. The upper level winds in this part of the world, not that strong. But then if one of those projected tracks of Erin is a little bit further ahead, it has the opportunity to get picked up by the jet stream. And pay particular attention to this one and this one. They're just a little bit further ahead. And watch what happens. They get picked up by the jet stream, and they start flying ahead of the rest of the pack. The rest of the pack left behind. The majority of model scenarios there are slower. They're leaving it behind. But these two and a few others start to race ahead. So 24 hours later, they're miles ahead. And this shows why predicting the track of hurricanes when they join the jet stream, when they interact with the jet stream, can be so tricky. Because this is essentially chaos theory. A subtle change at the start of the forecast, the point at which they approach the jet stream, can have significant differences later on, because those that are join the jet stream just a little bit earlier than others will get pushed along much quicker. So by 6 a.m. Bank Holiday Monday, a couple of tracks there have Erin approaching the UK. Most, though, are just that little bit further behind at the start of the weekend. They don't get picked up by the jet stream. So just playing it forward again. Is it playing? Oh, we've reached the end of the timeline. That's okay, because I can put that on, which shows the completed tracks for Erin, and this is for the whole lifetime of Erin. And what this shows, 50 or so tracks for Erin from 50 computer simulations of the atmosphere, is that there are, I don't know, 5 to 10 that have it out to the west of the UK, but the majority actually push it further south. So there are two scenarios coming through here, one most likely and one much less likely. The most likely scenario is that Erin doesn't get picked up by the jet stream through the weekend. It just misses out on the opportunity to be carried by these high altitude winds and just slowly meanders south again. Now, it's moving over waters that are relatively warm, but not as warm as you'd need, 26.5 degrees Celsius, to fuel the hurricane. Also, you haven't got the jet stream, you haven't got that big temperature contrast in the atmosphere that exists near the jet stream that helps to fuel a mid-latitude low. So it's lost its fuel source. So in all of these, the majority of the tracks that keep it to the south of the jet stream, they just basically fizzle Erin out into an area of fairly weak low, bringing showers to the Azores, which are here. And no big deal, right? Well, apart from the Azores, well, there'll be some heavy rain. Other tracks push it along the jet stream, and the jet stream keeps it relatively deep, and they push it, this is the less likely scenario, they push it to the west or northwest of the UK by early next week. So that's the less likely scenario. What are the consequences for the UK's weather with both of these scenarios? Well, this is where it matters for the UK and for Bank Holiday Monday. Let's put the pressure chart on here, because actually what you're seeing, the pressure chart here and the jet stream, this is from the Met Office computer model run. So this is one model run in which Erin doesn't get picked up by the jet stream. So this is in line with the majority of those other ensemble model runs. And in this scenario, that jet stream picks up another area of low pressure and sends it into the southwest of the UK for the start of next week. This is Bank Holiday Monday with some rain arriving into the southwest. So that's the scenario in which Erin doesn't get picked up by the jet stream and fizzles away near the Azores. Or in some solutions, it does that, fizzles away briefly, and then it returns to the UK later next week as another area of low pressure. But initially, in both those scenarios, either it fizzles away or it eventually reaches the UK by the end of next week. In both those scenarios, we do see another low turn up at the start of next week. That isn't Erin, but it's this area of low pressure. Now, in the less likely scenario, in which Erin ends up being picked up by the jet stream, in that scenario, it acts as such a force of nature on the jet stream that it actually pushes it further south across the Atlantic for the end of the weekend and builds a ridge of high pressure just to the east of the UK. So it causes the jet stream to become a little bit more amplified. And whilst it's sitting to the west of the UK as this fairly large area of low pressure, actually, for Bank Holiday Monday, it brings fine weather before eventually that low crosses the country in the middle of the next week. So that's the less likely scenario. But interestingly, that was the most likely scenario, according to the computer model output, a day or two ago. So the models have changed. They've changed very subtly in terms of the speed at which Erin interacts with the jet stream or doesn't. They are a little bit slower with Erin joining the jet stream. The majority of them are. And as a result, we're seeing the more favoured solution bring Erin more towards the Azores, away from the UK, and allowing another low pressure system to sneak in with a flatter jet stream, as opposed to that more likely solution in which Erin ended up as quite a developed feature, sitting to the west of the UK for the end of the Bank Holiday weekend, drawing up warm and sunny weather for Bank Holiday Monday before eventually crossing the UK the middle of next week. And in that scenario, this area of low pressure just gets eaten up by Erin and stays out to the west for longer before eventually the unsettled weather moves in around the middle of next week. So those two scenarios have flipped in the last day or two in terms of what's most likely and what's less likely. However, whether or not Erin actually comes close to the UK, it's going to be an ex-hurricane. It's going to be an ex-hurricane, and when it hits the Azores, if it does, it's an ex-hurricane. It's not a hurricane. It's the same as these other areas of low pressure in the mid-latitudes in terms of the structure and the impacts and so on. So that's an important point to make. And what's also an important point to make is that whether or not the remnants from ex-hurricane Erin reach the UK, the impacts from Erin will be felt throughout the rest of summer from the start of next week because of what it does to the jet stream. I'll be covering that in a moment, but before we get into that bit of the deep dive, let's take a look at the current state of the jet stream because it's very weak and wriggly. It's essentially pushing way up to the north of the UK. This is Thursday. Next couple of days of weather are covered in the national weather videos, so we'll just look at Thursday for now. And by Thursday, weak jet stream, just very wriggly across the northern hemisphere, not much energy in it, allowing this area of high pressure across the northwest of the UK to build in more widely for Friday and into the start of bank holiday weekend. So that's the situation for Saturday. High pressure fairly widely, not entirely sunny. This is Saturday in terms of the weather and the temperatures. You can see quite a lot of cloud. Yes, we've got high pressure over the UK. Yes, many places are dry, but a lot of cloud and some showers into the west and the northwest. Obviously not a bank holiday for Scotland. Showers here and also showers for Northern Ireland, northwest England. Fairly cool compared with a lot of the instances of high pressure we've had so far through the summer. We're talking about temperatures into the high teens and low 20s in the south. By Sunday, a bit more sunshine comes through. That high moves to the east. We see a bit more of a southerly breeze, quite breezy there towards the southwest, but with more sunshine around, temperatures lifting a degree or two, feeling a touch warmer. And again, a few showers here and there, but not much. Here is the low that I mentioned, being picked up by that jet stream. And what I'm going to show now is why that portion of the jet stream is a direct consequence of Hurricane Erin and why Hurricane Erin is going to shake things up quite significantly across the northern hemisphere, at least the North Atlantic and Europe, for the last week of summer. And to explain why, I'm going to draw a little picture. Bear with me, my art skills are not as good as many of my colleagues, but I will attempt to show this in a diagram at what's happening to the atmosphere from the surface up to the level of the jet stream when a hurricane moves into the mid-latitudes. First of all, imagine there are two columns of air in the atmosphere, one warm column and one cold column. Here's the surface down here, and up here we've got the jet stream. But this column of air is warm, this column is cold. Now, often in meteorology, we talk about pressure levels, not just heights above ground, but pressure levels. So you'll be familiar with high pressure and low pressure. That's where we look at the actual mean sea level pressure at sea level, and we talk about highs and lows, and the air tries to move from high pressure to low pressure, but it's deflected to the right because of the Coriolis force. That's the force that is the result of the Earth spinning. So as the air moves from high pressure to low pressure, it's deflected right, and the air moves clockwise around high pressure. So we talk about pressure at the surface, but we can also talk about pressure levels through the atmosphere. The higher in the atmosphere you go, the lower the pressure because there's less air resting on top of you. Also, the warmer the air, the higher up it expands. So if you imagine heating up a parcel of air, it's expanding. The molecules are racing about a lot more. The air builds and expands. So this warm column of air is expanding from the ground upwards. Now, if you imagine where the pressure is 1,000 millibars or hectopascals, it's going to be close to the surface. Let's say this is 1,000. It's going to be a similar height in the warm column as the cold column. So let's say, for the sake of argument, that's the same height. Now, if you go further up in the atmosphere, the air is expanding upwards. So for the warm column, the level at which the pressure is 500 hectopascals is up there. And then for the cold column, it might be a bit lower because it's not expanded as much. It's down there. So the air is expanding. This air is rising. Then there's this tilt like that. So there's this tilt from 500 over the warm column and 500 over the cold column. That then becomes more and more enhanced the higher up you go. And by the time you get to, say, 300 up here, it might be really quite high up under the warm column of air. So let's say it's 35,000 feet over the subtropics, but over the pole it might be 25,000 feet. So let's say it's here, 300, and you've got a much more enhanced tilt. And this is like creating a little hill. If you were driving a car over here, then you'd race down there, and basically that's similar to what the air's doing. The air wants to move from high pressure to low pressure, so you get this strong wind starting to blow from there to there because of the expansion of the air, because the air is rising higher. The air here is also moving from high to low, not quite as strong, and down here it's barely moving at all, just a puff of wind. So the air is moving faster the higher up you go, but it's not actually moving directly from the warm to the cold column, and that's because, as I mentioned, the Coriolis, let's say you've got warm here, and you've got cold here. So up at 300 hectopascals, the air's trying to move that way, but because of the Coriolis force, just as it goes around highs and lows in a certain direction, it will also be deflected to the right here, so it actually moves there. That strong wind that I mentioned, at that height is going clockwise around the warm column of air. That's the jet stream. It's deflected to the right. So this essentially is why you've got the jet stream. If you imagine a bigger picture here, the northern hemisphere, you've got warm air in the subtropics and the tropics. That's much thicker, so it's expanded upwards. But the air around the poles is much denser. So you've got the higher pressure at a certain height that wants to move towards the lower pressure at a certain height over the poles, deflected to the right, and you get the jet stream forming, where you get the greatest contrast between the two, the greatest horizontal temperature gradient. Also, in the summer, this is warm, this isn't quite as cold, so the poles heat up more in the summer than the tropics heat up. There's a bigger difference between the summer and the winter for the poles. So the jet stream becomes weaker in the summer, but in the winter, that cold air becomes much colder. So the level of 300 hectopascal pressure level drops much more significantly than the level over the tropics, and that's why you get this increased strong jet stream. That also applies when you throw a hurricane into the mix. So let's take a look at what Erin is doing, and the best way to do that is to put on the temperature at 300 hectopascal. Now, we've shown this in the deep dive a couple of times before. I always find it interesting to look at India, into the Tibetan Plateau, Pakistan, Iran. This is typically the hottest place on the planet at about 30,000 feet. That's what the temperature here is indicating. And there's a couple of reasons for that. First of all, if you look back at the last 24 hours, and where the hottest place on the planet was at the surface, it was Iran and Kuwait as well. Temperatures at 49, 50, 51 Celsius in this area. Here, you've got very strong sunshine, you've got big high pressure, it's a desert, you get a lot of thick air. You've got this expanding air from the surface, and as a result, you get this warmth at 300 hectopascals. So this is the kind of temperature you can expect up at that pressure level. Minus 24 above Iran, and India, Pakistan, also warm for a different reason. Here you've got the monsoon going on. So here's the rainfall. Got some heavy rain here, for example, and all that rain is the result of rising air. The rising air from the surface as a result of the rain season results in a lot of what we call latent heat energy added to the top of the troposphere, and all that energy as a result of condensation, the rising air, the cloud formation and the rain formation, that leads to higher temperatures also in this area. So these are relatively high compared with the rest of the world. If you look at, say, further into Russia, minus 48. So you've got this enhanced temperature contrast across, well, just to the north of the Himalayas, and that directly results in, we put it on, a jet stream. You can see the jet stream forming, not just there, but wherever we've got this temperature contrast. Particularly at this time of year, very cold over Antarctica, strong jet stream in the southern hemisphere. Jet stream further north, not so strong because that contrast isn't as great from the North Pole into the tropics and subtropics until you introduce a hurricane. Now, I showed you the temperature at 300 hectopascals over India and Pakistan and Tibet, minus 24 typically. But that's not currently the warmest place on the planet at that height. Remembering that this is about 35,000 feet in the atmosphere. And the warmest place on the planet, really does stand out, is Hurricane Erin. This is 11 o'clock UK time on Wednesday. If I just pick the centre of the hurricane, it's minus 20, minus 28 on the outskirts. So it's really quite warm compared with the same height around the surrounding areas. And what is interesting is what happens next. I'm going to skip forward to, say, Saturday, maybe just a touch back, and I'm going to put a temperature on, let's remove the jet stream from it, let's put a temperature there, minus 38 Celsius, and a temperature on what is soon to become ex-Hurricane Erin. And you can see in that short distance off the eastern seaboard of the US, off the east of Canada, a temperature contrast of, well, 17 degrees. In that same area, if we go back a few days, it's a much lower temperature contrast. So it's turning a little bit colder here, but much warmer further south. And this temperature contrast directly results, and you can see the lines there indicating where you've got a significant temperature contrast. If we put the jet stream on, that's this core of very strong winds developing in the jet stream. So, comparing Wednesday, where the jet stream is fairly weak coming out of North America, with not much of a temperature contrast. These lines are fairly spaced apart. What happens is this cold air stays in place, but Hurricane Erin introduces much warmer air from the south. All these lines bunch up. So we're going from Wednesday, watch what happens, to the jet stream and these lines to Saturday. The lines are bunching up. The jet stream becomes more powerful as well. That is the direct result of Hurricane Erin pushing north across the North Atlantic. It's causing this, what we call jet streak. And it's that jet streak that then goes on to pick up an area of low pressure that isn't Erin, but is looking like it's going to hit the UK early next week onwards. And that jet stream, as you can see, once it's set up, it's going to stick around for some time. It's not just going to send us that low, it's likely to send us another low. It might even send us a low that contains the remnants of ex-Hurricane Erin. But whether or not it does, Erin has already done its job. It's already caused the jet stream to fire up. Now, if we compare that late Sunday with Wednesday, barely a jet stream at all. It's very weak, it's very wriggly. Then Erin comes along, boom, causes this strengthened jet stream, which then travels across the Atlantic, and by early next week, we've got a stronger jet stream, We've got more low pressure coming along for the UK. We've got a big change from high pressure, from settled weather, to much more unsettled weather for the last week of summer. And that's the direct result of Erin. So if you're asking the question, will Erin affect the UK's weather next week? Well, one answer is we're not really sure which track Erin will take. It could bring its remnants to the UK at some point, but it could well stay away. However, the more important question is actually how will it strengthen the jet stream, and how will that jet stream bring us other lows that are not necessarily Erin? And that, I think, is the more interesting question here, because either way, whether or not it hits us as an ex-hurricane, it's still likely to bring us a big change to more unsettled weather for next week. And that's really shown quite clearly with this. This is a summary of the weather patterns going into next week and the kinds of weather patterns the most likely for the UK's weather. Now, the first few days of this forecast up to Saturday, the reds are in charge. The reds indicate high pressure close to the UK. So here's the most likely weather pattern for Friday, the 22nd of August. We've got high pressure sitting in a similar place to the northwest of the UK. A cool northeasterly breeze, but most places settled. Then, as we go into the start of next week, these blues start to make an appearance, and you can see the increased influence from these Atlantic lows that are represented by the blue colours. Now, exactly how that manifests day to day, it's too early to say because there are so many variables involved, not least how an ex-hurricane is going to interact with the jet stream and how the jet stream is going to interact with an ex-hurricane. But what looks most likely is that that ex-hurricane fuels the jet stream brings a big change to the UK's weather into next week, brings an increased likelihood of low pressure, showers, spells of rain, and increased wind as well. Of course, we need the rain, but it might not be welcome for people who want to enjoy the last week of the summer holidays. It does look a little bit more likely that autumn will make an early appearance. But we'll keep you updated right here at the Met Office on the day-to-day details. Alex will have the very latest in the 10-day trend tomorrow, so make sure you watch that as well. You can find that on the Met Office YouTube channel and our Spotify channel as well. But for now, that's all from me. Bye-bye.